you open up this can of worms about the Greeks caring about mathematical proofs. So now we have to go there as our final big question.
Sure.
One of the courses you teach at Columbia is titled What is Mathematics?, where you explore these similarities or differences between different forms of mathematics. So the mathematics employed by the Egyptians, the Greek, the Indian, Chinese scholars, and of course, modern mathematics. I'm going to commit the cardinal sin of asking you to summarize an entire college course in one answer. But what are some of the glaring similarities or differences you have noticed? Of course, we spoke about mathematical proofs. The Greeks used it. Probably the Indians and Chinese scholars did not use it. What are these differences, common threads that you've seen, and how does that change the type of mathematics they use?
Yeah, good. I mean, so first of all, I should just clarify this. It's not a class I regularly teach. It was a seminar that my colleague Chaim Geifman, who's a logician, actually wanted to teach together, and it was really fun. And right, it was historically based, which is not so usual in philosophy of math or foundations of math. I mean, one criticism you could have of it is that it's ahistorical. And if you're really asking questions like what is math and stuff, you should be thinking about the history, not just, working in some particular system of logic and then proving theorems or something. So I'm no historian, and I found it fascinating to begin to learn about that stuff. And I've been really interested since. I'm so glad that I did, because there's a remarkable amount of contingency in things to do with math that I did not appreciate. And I was coming from a place of thinking that math is quite contingent. So I'm talking about extra kinds of contingency, right? So the most glaring is simply the idea that math has anything to do with proof. I mean, if that, I thought that was true by definition. Yeah. Like, what is math? It's where you prove things. I don't know. And of course, I knew that very, very basic math about counting pebbles or something doesn't involve proof, but any established mathematical tradition would involve proof. And as the historians will tell you, that's definitely not the case. In fact, it's kind of a anomaly and requires explanation, that people have tried to offer explanations in terms of actually Athens being a democracy and requiring evidence and argument and stuff like this. But why did the Greeks care about proving things? Why didn't they just want to know what was the case? Right? Why don't you just want to know whether the Pythagorean theorem is true? Who cares about a proof of it? And there are two main answers to that, I think, in the literature, and they correspond actually to the two kinds of values you could have in light of this AI stuff. One is you want understanding, and proofs facilitate understanding. They answer the question why. Notice that is like the Michael Harris view, where the AI stuff, if it doesn't answer why and I can't understand it, it's irrelevant.
Yep.
The other is certifying or making certain the claim. So I want to know, I don't just want to think it's probable or likely or it seems plausible. I want to certify. That the AI stuff might do. But of course it might do even though you don't understand. So anyway, so there's different accounts of why the Greeks did what they did, but they were unusual in this way, and not just unusual in the sense that, so for example, the Indians had very advanced mathematics that wasn't proof oriented in the same sense. Yep. Chinese had very advanced mathematics that wasn't proof oriented in the same sense. The Mayans had advanced mathematics in certain respects that, that's just, wildly different in some ways. But it's not just that. It's that the Westerners themselves, right? Before the Greeks didn't have proof. Try doing anything interesting with Roman numerals, right? So immediately after, also they didn't have the proof was not a value of great significance. But before, in the Mediterranean, the Mesopotamians, incredible when you think about how early they're doing what they're doing. Just incredible, but proof was not central, even when kind of recreational math was. So it wasn't just practical either. They were doing recreational math. But so anyway, And then, in medieval Europe, proof was no longer central. Newton lamented that his Principia Mathematica doesn't follow the method of the ancients exactly, and so forth. So and this is an example of where, math and physics became so entwined, and actually you could say that physics was leading to the new math, and it was only math later that was catching up and making rigorous things and so forth. But we only picked up that thread in the 19th century, really. So you have this idea of rigor, and I should just highlight again, I'm no historian. I'm sure there's some historian knows the answer to this, but I should highlight the awkwardness of the following situation. Aristotle invented logic. We then have in the West, and then we have Euclid's Elements. Euclid's Elements is not rigorous by the standards of what was thought to be logic. So that's another thing that's weird. Proof, whatever it is in the Greeks, is not what we now think of, which is following logically according to our notion of logic. So anyway, it was only in the 19th century that this idea of, this obsession with proof, I think, reemerged, and people like Dedekind and Peano and Russell and Frege and so forth. And in the 19th century and in the 20th century, it developed even further. But that's a dramatic contingency in my view. It's not a contingency about the content. So it's not an example of a case where, like, the Mesopotamians thought there weren't infinitely many prime numbers, and or let's say the Chinese thought there weren't infinitely many prime numbers, and the Greeks thought there was. But it's a case where something so essential, it seems like, to math is actually the exception historically. It's not just not universal, it's the exception. So whatever math is, if we're actually trying to do justice to the historical record, it's not proof. And I think that this, this is again a kind of live question: why care about proof, especially now with the AI stuff? So anyway, that's the main contingency that I noticed. But there's lots of other things one can talk about when thinking about the history of math and how it relates to the philosophy of math. So
interesting that we spent the last couple of hours talking about the importance of proofs, and now we're talking about whether proofs need to exist or not.
Right. Yeah.
Yeah. Everything's been a lie.
Yeah. Trust me.
I'm trying.
Okay. Please.
It's a lot. Like, it's like you offer the red pill or the blue pill, right? And this has been that day for me.